So we're going to take a look at this problem. If a ball bounces off a horizontal heavy steel plate with a velocity of 15 meters per second at an angle of 20 degrees, what must its initial velocity and angle of impact have been if the coefficient of restitution is 0.6? So this is interesting in that it's back to front to most of the problems like this that we might have approached in seminars, with looking at the bounce of the ball and having to calculate its initial velocity and angle. Now, as always, it's a good idea to start with a diagram showing what's going on, and that will help us to understand what we need to work out. So we will initially calculate what the vertical components of that final velocity and angle will be. So using a little bit of fairly straightforward trigonometry, we can work out that the vertical component of the bounce would have been 5.13 meters per second, and the horizontal would be 14.1 meters per second. Now I would award getting to this point 3 marks, having understood what the problem is and calculating the components of the velocity given. We can then move on to the next part, understanding the conservation of motion. We can see that the mass of the ball multiplied by its initial velocity plus the mass of the heavy steel plate multiplied by its initial velocity will be equal to those masses multiplied by the final velocities. However, we haven't been given an initial velocity for the heavy steel plate or the final velocity, and neither have we been given any masses, so we can assume that the velocity of the heavy steel plate will remain at 0 throughout, or very close to 0, as it's a heavy object and will barely move from the impact of the ball. So to work out the vertical component of the initial velocity, we can use the coefficient of restitution. Now we know that the formula for this from our formula sheet is minus e will be equal to the final velocity of object 2 minus the final velocity of object 1 divided by the initial velocity of object 2 minus the initial velocity of object 1. As we've said, the velocity of v2 and u2 will be 0, so we can change that to equal minus e will be equal to minus 0.6. It's important to watch signs when we're working with this, because that will give us a final direction. So we're looking at finding minus u1 will eventually be equal to minus 8.55 meters per second. So we're getting close now. We now have the final velocity, the initial velocity for the ball in the vertical component. And note that it is travelling in the opposite direction to v1, which makes sense. The ball would have been travelling in a downward direction when it initially impacted this heavy steel plate, and in an upward direction after it bounces. And the horizontal component, now we know that according to Newton's first law, unless an object under motion is subjected to any other forces, its velocity will remain constant. And we're not told about any drag forces to consider, so we can ignore those, meaning that again the initial velocity will be equal to the final velocity of 14.1 meters per second. And then we're back to trigonometry and Pythagoras to combine those forces or velocities into one velocity, from which we'll find we get to 16.5 meters per second at an angle of 31.2 degrees, which gets us to the points that we wanted to find. Thank you very much.